the patients that are coming in, you noticed that they are coming with high blood pressure. What will you do next? Let's type on the chat box. Okay, Jamil Garba says he will measure the blood pressure first. Samsudin Pedro says to know how the drugs they are using, taking patient history. All right. Thank you very much to those that have responded thus far. Congratulations to all of you. You are the researcher. Um, in research, we start by observing, maybe in our clinical practice or even in our surrounding or in the literature, whatever we read, we make an observation, then the research process begins. So that is what we do in research. We start the inquiry process. Can we go to the next slide, please? Thank you. You can continue to, yes, you can continue to respond. We'll look at that. Let's look at our learning objective. At the end of this presentation, we expect that you'll be able to differentiate between biostatistics and research methodology, evaluate case studies to appraise real-world impact, critique flawed designs using methodological principles. So these are what we hope to achieve in this presentation. So let's go to the next slide, please. Now let's look at biostatistics and research methodology. Now I want someone to tell me, the how biostatistics applies in their research. So you either type or you unmute yourself or you raise your hand, you'll be unmuted. Tell me how biostatistics applies in your research. Then we can go on from there. Anybody? Anybody to respond to that question? How does biostatistics apply in your research?
For me, thank you very much, lecturer. For me, I think for biostatistics, just apply for collecting, analyzing, and interpreting the data. While the for research methodology help us just to make a plan and having the approach that can lead to those data collection.
Okay.
Yeah. Thank you so much.
Thank you. Thank you for your response. I've also got some response from the charts. Ifeyiwa says you want to know what is happening, who is affected, and how best any challenge can be tackled. Biostatistics is relevant in comparing results gotten from research. That is coming from Latifat. Thank you very much to those that have responded. Yes, your responses are valid. Biostatistics is a branch of statistics because statistics is a field that is applied in many other fields, including business, education, psychology, agriculture, economics, and all that. But when you now apply statistical tools and methods to analyzing health data, then you are talking about biostatistics. As we're going to see from some of the examples that we have there, biostatistics is the foundation of research in any field. So long as you are going to do quantitative research, then you need biostatistics. If you are doing quantitative research, you cannot do without biostatistics. It is the foundation because it's going to help you to analyze your data. It will help you to interpret the data, and it would also help you in terms of design of your instruments and all that. So biostatistics is very, very key in quantitative research. Now, with regard to research methodology is the systematic framework that will guide you in selecting your study design. So research methodology will allow you to know what is the appropriate study design that you are going to use. If I ask a question, for example, I'm doing a study to determine the prevalence of diabetes among adult outpatients in Rwanda, what will be the appropriate study design for that kind of research objective? So to determine the prevalence of diabetes among outpatients attending maybe Rwanda medical Rwanda military hospital. So what is the appropriate study design for that kind of a study? You can unmute yourself and respond. Anybody? Dr. Lucy, you are recognized. Dr. Lucy, please go ahead.
Yeah, hello, good evening, everybody. I think a cross-sectional design will be suitable for such a research.
Very good. Thank you very much for that. So we
Yeah,
have people knowledgeable about biostatistics and their research methods in our program. Yeah, that is correct. So biostatistics is going to guide you as to, research method is going to guide you as to the correct design that will enable you to answer your research question. Number two, it is going to help you in the data collection process. Because when you look at the study design in relation to the study objective, then you are going to now look at the most appropriate data collection procedures. What is the relevant tool that you can use, or what are the relevant tools that will enable you to achieve your research objective or answer the research questions? If you are doing a quantitative study, for example, are you going to use a questionnaire to collect data? Or are you going to combine a questionnaire with an observational checklist? Because there are studies that would use multiple tools to collect data. There are studies that also involve some lab work. There are studies that will involve measurements of some variables like the study on diabetes is going to need a measurement tool to diagnose whether a participant or a respondent is diabetic or not. So it is going to guide you as to what data collection tools will be appropriate and how should you go about collecting your data. Number three, research methodology will also help you with the analytical approaches to ensure valid, reliable, and reproducible scientific inquiry. For every research that we do, whether it's quantitative or whether it's qualitative, we want to make sure that someone somewhere can also replicate that study without having to ask you questions. So you are going to detail the methodological approach that you have used to the extent anywhere can replicate the study. If you conducted experiments, they can also follow the steps and conduct a similar experiment. If you interviewed participants, they can also use a similar tool as yours and interview their own participant. Then they can compare their findings to your findings. So research methodologies, they help us achieve this. Let's go to the next slide, please. So why is biostatistics important? So these are divided into two parts. The first part, we are looking at the importance of biostatistics in health research. The second part, we're looking at importance of biostatistics in public health itself. But generally, you can say that there are three main reasons why biostatistics is important in health research. Number one, it provides evidence-based decisions. Because biostatistics is the decision support system that helps you to transform data into actionable information. We all know that for you to make decisions, you need information. For you to have information, you need data. And biostatistical tools will help you to convert this data to information, which can be useful, usable for decision-making purposes. Number two, it helps you in terms of controlling bias and error. You are going to see some examples later, but biostatistics will help you to detect confounding, sampling bias, and p-hacking. We are going to discuss those ones later. Number three, it guides allocation of resources, which means biostatistics impacts public health. Public health decisions cannot be made without having reliable, accurate data. So they help policymakers to allocate limited resources. Let's look at an example here. There is this study conducted in Scotland. The study demonstrated that pravastatin reduced LDL by 26% and cardiovascular disease events by 31%. Biostatistics was used in that study to establish causality, not just correlation. Let's go to the next slide. Now, let's look at the importance in public health with a focus on malaria control. Data-driven interventions are critical for malaria elimination and control in malaria endemic region. Now, the key contribution that we have seen is one, outbreak predictions. Through biostatistics methods, the application of biostatistics methods, we saw in Zambia that GIS and climate models predicted outbreaks of malaria. Then intervention impact. ITNs, insecticide-treated nets, reduced under 5 mortality by 50%. So we can see that without biostatistics, there is no way you can model. In advanced biostatistics, we deal with modeling. Okay, so in advanced biostatistics, we model to be able to predict what an outcome will be given some predictors or independent variables. So let's go to the next slide, please. Now, elimination strategy in Sri Lanka. Case climate synergy achieved malaria-free status. So the outcome of all these studies is that targeted resource allocation. They achieved targeted resource allocation. So biostatistics methods helped decision makers to make targeted resource allocation. So let's go to the next slide, please. Now, who are the key players? The key players are biostatisticians and methodologists. Of course, there is an overlap. A methodologist must have, if you are a quantitative researcher, you must have some background in biostatistics. Then a biostatistician would also have a knowledge in research methodology. So there is that overlap. So now, if research were a movie, then we consider biostatistician as the editor that will ensure that data tells a clear story. Because your data, when it is now processed to become information, should be able to tell a story. So that is why for postgraduate research, when you are defending your thesis, for those who are, because some of our participants are at that level, they are defending their thesis, or some are still dealing with data analysis. When you are defending your thesis, the examiners may ask you, okay, we have seen your findings. So what? That is, why should we care about this finding? What is it going to add? So biostatistics will help researchers to ensure that their data is telling a clear story. So biostatisticians design analysis plans and they check for bias. Methodologists ensure study design answers the right type of question. Because as you are going to learn with my colleagues in study design, which is the next lecture coming up next month, there are different study designs, but basically they are grouped into two. We have observational designs, whereby the researcher does not intervene, and we have experimental study designs, whereby the researchers will manipulate the exposure or the intervention that is given. So aka placebo and experiment group. So you have an experiment group that will receive an intervention or an exposure, and you have the placebo group or the control group that will receive placebo. So these are basically the study designs. Then we have subtypes within each one. For observational study design, you can have case series, you can have cross-sectional studies, you can have case control studies, you can have cohort studies, which can be either prospective or retrospective. Then for experimental studies, you can have real experiments, you can have coagil experiments. Real experiment, an example can be your randomized control trials. So they are going to ensure, methodologies will ensure that your design is appropriate for the kind of question that you have asked, the research question. Or if it is an hypothesis, there are some designs that will expect that you have hypothesis. So if you have hypotheses, they will ensure that the hypothesis will be testable using an appropriate design to be able to, accept or reject the null hypothesis. Let's go to the next slide, please. So now we want to contrast biostatistician and methodologist. What is the role of a biostatistician? A biostatistician is a data analysis expert. A methodologist is a study design architect, is an expert in study design. What is the primary focus of biostatistics? So the primary focus is on statistical modeling and statistical inference. As we are going to learn in data analysis occurs at 3 levels. You have univariate analysis, whereby you consider one variable. A variable is a characteristic or a phenomenon that changes with each measurement or observation. You take a variable, for example, age, you present it. Then we move to bivariate, which is cross-tabulating one independent variable against the dependent variable, usually 1, except you have a complex design. Then from bivariate, we move to multivariate. From the bivariate, the criteria is you select variables with p-value less than 0.2. So that's the criteria. Although many people erroneously assume that you are going to select variables with p-value less than 0.05. But the right thing to do is to look at p-value less than 0.2. Those are the ones you are going to select into the multivariate analysis, where you can now adjust for confounders and do some other adjustments. Because confounding variables, they are going to distort the association between your independent variable and the dependent variable. So at multivariate analysis level, we now have different categories. Okay, we have different categories of multivariate analysis. Some of them are very advanced. So part of what we do there is modeling. So you can model to be able to predict disease outcomes. Now, a methodologist will focus on research validity and bias prevention. So is your research valid? Because no matter how much your background is well written, if your methodology is then you have methodology, and we find that the means through which you are going to achieve what you promised to achieve in chapter 1 is not appropriate, then there is a problem. For example, if a study is cross-sectional, then you want to use methodologies that are suitable for accessing causality. That will not be appropriate. So that is what they do, the methodologies. Then the study phase, biostatistician will be more prominent at the analysis stage, post data collection. Then methodologies would be more relevant at the planning stage, pre-data collection. So when you are conceptualizing your study, methodologies will guide you as to which is the appropriate design, and is the design going to help you to answer your research question. Then the key tasks for a biostatistician include power calculation, for studies to have scientific rigor, for that study to be methodologically sound, or for your study to be able to generalize its findings, you need statistical power, which is linked to sample size. But most of the sample size calculations, this topic will be addressed by my colleagues in subsequent lectures. So most of the sample size calculation formula have built power analysis into the formula. Then we have regression analysis. We just use this as an example. What we intend to say there is that biostatisticians will perform analysis to establish whether there is an association or not. So regression analysis will help you to access that. And if you want to know the strength of the association, depending on the nature of the variables and some other issues, then biostatistician will also help you in terms of correlation analysis. The screen is okay, fine. Now, another thing is, I see this in comments by most of the participants. So we are going to address this to inferential statistics and reporting and presenting research findings, especially inferential statistics, interpreting p-values and okay, for a methodologist, they are going to help you with randomization. How do you ensure random assignment of participants into different groups, maybe to a placebo group, to experiment group? And randomization, among other things, helps you to address the issue of confounding. Now, confounding control is another thing that methodologies do, and bias assessment. So this is how both of them help you with your research. Now, together, biostatisticians and methodologies ensure that your research is valid, is reliable, and useful in terms of having impact on policy, clinical practice, and of course, contributing to literature. Can we go to the next slide, please? Now, these are the common pitfalls that we expect that we are going to avoid in health research. I want a comment on this one. I want someone to tell me what she or he understands about this. A hospital sees more ice cream sales correlate with drowning. Does ice cream cause drowning? Can someone respond to that? Does ice cream, when you see that in that data, when you analyze, I mean, the hospital noticed that more ice cream sales correlate well with drowning. So there is that correlation between increase in ice cream sales and drowning. So the question is, does drowning increase? I mean, does the ice cream cause drowning? Musa Adam, you are recognized, please. Musa Adam, you can unmute and contribute. Okay, who else? Whose hand is on? Okay, okay, okay. Bamidele, Sabimana, Emmanuel, Ilejo, all of you said no. Now, the question is, what is your observation regarding this kind of conclusion? Okay, I want someone to respond to that. The response is in terms of confounding. In terms of confounding, a confounder is a variable that is associated with both independent variable and the dependent or outcome variable. It confuses the association between the two. Okay, so there is a confounder there. That's the issue uh, that is of interest. Hot weather, because the research was done in the summer months, hot weather increases ice cream sales, and of course, people were going to swimming. They are going to swimming pool to swim. Okay, so the fact that the weather was hot was a confounding variable. So hot weather was a confounding variable. Unless we adjust for the confounding variable, we cannot make any conclusion that ice is associated with drowning. That is the a pitfall that we need to avoid in research. Correlation or association does not imply causation. So if there is an association between one variable and another variable without adjusting for confounding variables in the multivariable model, then our conclusion will be invalid. So a biostatistician will help you to ensure that your results are valid. They are not only valid, they are also reliable, and they can be useful for decision making and all that. So we need to avoid such uh, uh, pitfalls. There are so many mistakes that we make in our research in terms of biostatistics. I've seen studies because I review manuscripts for different journals, including BMC Public Health Plus One and some of them. There's some researchers that will lay claim that are not valid. For example, someone responded correctly that when you have a prevalence study, the appropriate design is a cross-sectional design. We have seen researchers that will conclude that, for example, they will say, this study reveals that smoking causes lung cancer, and it's a prevalence study. It is a cross-sectional study. That is a mistake because cross-sectional study, one major limitation of the cross-sectional study, you are going to discuss this with my colleagues that will take you through study design, is what we call lack of temporality. In a cross-sectional study, we do not know whether the disease was preceded by the exposure or vice versa. The issue of which one comes first. Is it the egg or the chicken? Many people will say egg. Many people will say chicken. The egg-chicken conundrum applies to cross-sectional studies. The reason is because you will measure both exposure and outcome at the same time. So we do not know whether they were exposed before they became diseased or whether they were diseased before they became exposed. So these are some of the errors we need to, or pitfalls we need to avoid. Another one is sampling bias. For example, testing young adults only in a drug trial. Then another one is p-hacking and data dredging. Does anyone knows or has anyone heard of p-hacking before? What does that mean? Anybody? You can unmute and respond. P. Akin. What does it mean? Who is going to respond? Okay, Adi, you are recognized. Anybody else? Okay, let's continue. Let's continue. Next slide, please. Okay, let's look at examples of what we have said. I've given you an example, but let's look at some published papers. This is a published paper. You'll see the reference to all the studies that are mentioned in this presentation. Hormonal replacement therapy and cardiovascular disease risk. Observational data in the 1990s found that HRT was associated with 40% lower cardiovascular risk. Now, the limitation of these observational studies is what we call healthy user bias. So the recipients of HRT were those that were healthy at baseline. So that is the limitation of that observational studies findings. Now, RCT evidence in 2002 found that like we have Women Health Initiative trial. It is a study that assessed hormonal replacement therapy effect on post-menstrual women. So it shows that 29% increase in cardiovascular risk was associated with HRT. So we know that RCT is the gold standard if you want to eliminate confounding. I mentioned earlier that the fact that we are randomizing in a randomized control trial helps us to eliminate confounding. So the lesson here is that association is not the same as effect. If you are looking for association, you are going to do observational studies, cross-sectional study, they can find association. So it will be wrong of anyone to conclude that there is causation between independent variables and dependent variable in cross-sectional studies, for example. So you cannot say that smoking cigarette causes lung cancer in an observational or a cross-sectional study. So effect means causation. So association is different from causation. So if you want to establish causation, you conduct experimental study, especially randomized control trials, because there are non-randomized control trials also. And there are experimental studies that are not real experiments. They are called quasi-experiments. These are things that you are going to. Dr. Lucy said P-hacking means manipulating data, manipulating of data analysis. That is correct. And that is something that, okay, we'll still talk about it. It will come, but that is correct. Thank you, Dr. Lucy. Now, let's go to the next slide. Sampling bias in clinical research. We are using an example of a COVID-19 drug trial. The study flaw is that the hydroxychloroquine trials enrolled predominantly young, healthy adults. So there is a critical omission of elderly, the 65 and above patients with the elderly patients, and of course patients with comorbidities. And other studies have found that comorbidities like hypertension and diabetes, they are also associated with COVID-19 mortality. Now, the consequences are: one, 72% lower efficacy in real world population. So the trial found that hydroxychloroquine was effective, but in the real population, the efficacy was not as expected. There was emergency use of the emergency use authorization was revoked within 3 months. So how do you prevent this kind of problems? You are going to use precise tool framework. So it stands for pragmatic explanatory indicator summary. So it's a clinical trial tool that is designed to balance both real world applicability, which is called pragmatic, with scientific rigor, which we call explanatory. Let's go to the next slide, please. Next slide. P-hacking and data dredging. Let's look at an example. Like Dr. Lucy said correctly, P-hacking means that you are manipulating data or manipulating your analysis so that you achieve statistically significant results. That's what P-hacking means. Some students here, they are fond of tampering with the results or the analysis. They are not comfortable with null hypothesis. They don't want non-statistically significant association. So they would either manipulate the data until they achieve statistically significant association, or they would manipulate the analysis. So that's what P-hacking means. So let's look at some examples. Cross-sectional claims in 2019. 68 cross-sectional studies associated breakfast skipping with obesity. What is the flaw here? P-hacking, analyzing 20 plus dietary variables, only reporting significant ones. So this is a common practice. It's not a good practice. It's not ethical, and it violates scientific or what you call research integrity. It's not something that you should do. You would rather allow biostatistician to relook your data or relook your analysis with a view to seeing where lies the problem. Let's look at what RCT evidence showed in the same year. Randomized control trials of 1,028 patients showed no causal relationships. There was no causal relationship between skipping breakfast and developing obesity. So that is it. So how do we prevent P-hacking? In a randomized control trial, there is pre-registration of analysis plan. Then boom for any correction for multiple comparisons can be done. So when you do multiple comparisons, because multiple comparisons can lead to what we call false positives. So if you fail to correct for multiple comparisons, you are going to have false positives. Let's go to the next slide. Now, we also want to look at why methodology matters. Looking at Lancet's retraction of autism vaccine study. A study by Wakefield and others in 1990. There were methodological failures. One, sampling. When you look at the sampling, they were non-randomized. There were 12 participants, no control group. Number two, bias. Participants recruited via litigation. Number three, temporality. Autism symptoms predated vaccinations in 5 cases. Can you imagine? There were 12 participants, almost 50% were already exposed. They were already having symptoms of autism. So the study was flawed. Let's go to the next slide. Now, another one is statistical misuse. No multiple testing correction. They were doing multiple testing. And as we said, when you are doing multiple testing, you are supposed to correct for that using bone foreigning or some other uh, multiple testing correction methods. That is going to increase false positives. Then causation inferred from correlation. The study found associations, but the researchers concluded on causation, or what we call effect. What was the effect of this, or the consequences of this? Uh,
So we can't hear you again. I think your mic is muted.
Next slide, please. Can you hear me?
So, Doctor, we did not hear your previous explanation. I think your mic was muted.
Oh, okay. I was saying that statistical misuse, they conducted multiple testing without correcting for multiple testing because is going to increase false positives. And they inferred causation from correlation, and that is not correct. You cannot infer causation from correlations. You can only infer causation from measures of effect if it was a randomized control trial. And the consequences are 286% increase in measles cases from 2001 to 2019. Then the cost was 2.1 billion USD in measles outbreak containment.
Hello, sir. I think the microphone is muted again.
Sir, your mic is mute. Please, we cannot hear you.
Can you hear me?
Yes, we can. Yes, we can.
Oh, okay. Hey, there's technology. Sometimes we don't understand. Okay, so we have actually come to the end of the presentation. Next slide is just the summary and the key take-home message. So let's go to the next slide, please. Then we will take some questions. Now, the summary is that biostatistics turns raw health data into life-saving decisions. So biostatistics is a veritable tool that will help you in your research to ensure that you get valuable information that can be used for decision making. So the final thought, the next time you see a health headline, you must ask this question: was the biostatistics done right? For those colleagues who are online with us, who are experienced researchers, they know that when we are reviewing or critiquing articles, we are looking for methodological flaws. So you don't just accept whatever that you see in a published article. As you can see from the different examples that we have reviewed, the fact that an article went through the peer review process does not guarantee that it is not without flaws. And methodological flaws can lead to your paper being retracted over time. So we need to avoid these pitfalls. Now, my final advice to us before I allow and welcome questions is that right from when you are conceptualizing your research, unless you are a biostatistician, please consult with a biostatistician to avoid all the pitfalls that we have discussed. And throughout the process of your research, make sure you work with a biostatistician. And I must also say this: some people are data analysts, they know how to analyze data, but they don't have the knowledge of biostatistician. They can press the keyboard and make use of statistical application packages like Stata, R, SPSS, and the rest of them. But if you ask them, what is the rationale behind this kind of analysis? I also saw that majority of the participants indicated that they would like to know which statistical test should be chosen for a particular uh, uh, research question. That's an interesting area that we are going to emphasize when we move forward with the program. Thank you so much for your active participation. It's quite enriching. Um, and we hope that you are going to even do even better with my colleagues that will present from next month. So I welcome questions. Let's have 3 questions. The rest you can type them. We are going to address them offline. Questions? Whose hand is on? Let me see. You can unmute yourself. Oh, Samsudin, you are recognized. Please ask your question. Please ask your question. Samsudin, unmute yourself and ask your question, please. Okay, you can type if you are hearing me. You can type if okay. Thank you all for your participation. We hope to see you next month. Bye.
Thank you, Doctor, for the beautiful presentation. We say bye to everyone and sorry for the problem of the technological issue. Thank you all for your support. We hope to see you next month. Bye bye.